Now consider the next application of the differential equation, that is the Newton's law of cooling. Newton's law of cooling states that the rate of change of temperature of the body is proportional to the difference between the temperature of surrounding and the body itself. So that is d theta by dt equal to minus k theta minus theta 0. So what is this theta 0? Temperature of the surrounding. It means that if we consider one room, so this is the temperature of that room or surrounding, you can say. And theta is the temperature of body. So surrounding temperature supposed to be constant here, theta 0. Right? Here supposed to be 35 degrees Celsius. So this theta 0, it is a constant quantity there. And here theta, it means that it's supposed to be one body having a temperature 100 degrees Celsius. After some times, definitely the temperature of body reduces, right? And that is why it is a minus. It's supposed to be reduces, means here decreases, and that is why here minus sign. So in this case, theta 0 is a constant, k is a constant, and variables are theta and t. That is the time t, and theta means temperature of the body at any instant or any time t. Example, the temperature of water initially is 100 degrees Celsius and that of surrounding is 20 degrees Celsius. If the water cools down to 60 degrees Celsius in the first 20 minutes, what will be the time required to fall temperature up to 30 degrees Celsius? So here this temperature of water cools down from 100 degrees Celsius to 60 degrees Celsius in first 20 minutes. So here we have to use Newton's law of cooling. Solution. Now step number 1. By Newton's law of cooling, d theta by dt equal to minus k theta minus theta 0, where theta 0 is the temperature of surrounding. So given theta 0 here means temperature of the surrounding. What is here? Here 20 degrees Celsius. So theta 0 equal to 20 degrees Celsius. And also the relation, note that here variables are theta and t. Here theta 0 and k are constants. So by the given values I can make this table, that is the t and theta. The temperature of water initially is 100 degrees Celsius. It means that here this is 100 degrees Celsius initially, means time is 0 there. So temperature was 100 degrees Celsius. If water cools down 60 degrees Celsius in the first 20 minutes, it means that after 20 minutes, so here time in minutes, temperature of water is 60 degrees Celsius. And what will be the time required? So we want to find time. So I will consider that is a T1 to fall temperature up to 30 degrees Celsius. It means that here we want when temperature of that water will be 30 degrees Celsius, what will be the time required? So by this theta 0, rate of change of temperature, this becomes now d theta by dt equal to minus k theta minus theta 0, which is the 20 now. So now separate the variables. So I am getting here d theta upon theta minus 20 equal to minus k dt. So this is equation number 1, which is a variable separable form. So now step number 2. So as it is a variable separable form, we know what to do with that, integrating both sides. So here integration d theta upon theta minus theta 0, that is equal to minus k dt. But now I am using here the limits of this theta and t here by using this known values. So how? When t equal to 0, what is the corresponding value of theta? It is 100 degrees Celsius. And when t equal to 20 minutes, what is the corresponding value of theta? It is a 60. So that is why here need not to consider integration constant, because it is a definite integral now. Now evaluate this. What is the integration of d theta upon theta minus theta 0? Definitely it is a log of theta minus theta 0. So here upper limit and lower limit 100, upper limit 60, and that is equal to minus k into t. Integration of dt is t, lower limit 0, upper limit 20. So here substitute, you know that upper limit minus lower limit means these are the limits of theta. So therefore upper limit is 60. So here what is the value of theta 0? We know it is a 20. So that is why here upper limit is 60. So I am getting here log of 60 minus 20 because these are the limits of theta. So I am getting it is a 40 minus lower limit log of 100 minus 20. So I am getting it is a 80 and that is equal to minus k. Here upper limit 20 minus lower limit 0. So if we simplify it, it means that by properties of logarithm log a minus log b, it is a log a by b. So I am getting here log 40 by 80 and that is equal to minus k into 20. So what is the value of constant k here? So I am getting k equal to minus 1 by 20 and this 40 by 80 I am getting 1 by 2. So that is why here log of 1 by 2. So this is equation number 2. Now we have value of k. Now again the same equation, that is equation number 1 from equation 1, which is a variable separable form. So once it is a variable separable form, I will integrate it. But now I will use one known values and unknown value. So by using that I can get a value of t1. So how? Let's see. Here again from equation 1. So it is now step number 3. Again from equation 1, which is a variable separable form. So integrate it, d theta upon theta minus 20 equal to minus k integration of dt and lower limit to 0. Note that here when t equal to 0, corresponding value of theta is 100 and when t equal to t1 means I am taking here unknown value. So what is the corresponding value of theta? It is a 30 and that is why I am getting here it is 30. So again the same, that is the integration of d theta upon theta minus 20. It is a log of theta minus 20, lower limit 100, upper limit now 30 and that is equal to minus k t, integration of dt is t. So lower limit 0, upper limit t1. So t1 is our target. So now log of upper limit. So theta is now 30. What is 30 minus 20? It is a 10 minus log of lower limit. So 100 minus 20, I am getting here 80. And that is equal to minus k t1 minus 0. So I am getting t1. So what is it? It is a log of 10 by 80 and that is equal to minus k t1. Now substitute value of k from equation 2. So what is the equation 2? I am getting here the value of k, that is a minus 1 by 20 log of 1 by 2. So that is why log of here 10 by 80 I am getting 1 by 8 and that is equal to minus k 1 by 20 log of 1 by 2. So this is value of k and into t1. We want to find value of t1. So that is why by simplification of this I am getting t1 equal to 20 into log 1 by 8 whole divides log of 1 by 2. So by calculator you can find this value. So what is it? Note that here use natural log. So I am getting here t1 equal to 60. So 60 minutes means 1 hour. Okay. It means that the time required to fall temperature up to 30 degrees Celsius is 60 minutes means 1 hour, which is your required solution. Now the next example, a body at temperature 100 degrees Celsius is placed in a room whose temperature is 20 degrees Celsius and cools down to 60 degrees Celsius in 5 minutes. Find its temperature after 8 minutes. It means that now time is given, we want to find theta. Means after 8 minutes, what is the temperature of that body that we want to find here. So or a body at temperature 100 degrees Celsius is placed in a room whose temperature is 20 degrees Celsius and cools to 60 degrees Celsius in 5 minutes, means up to this it is same. Find its temperature after further interval of 3 minutes. It means that already 5 minutes plus 3 minutes means 8 minutes. So that is the same. So here we have to use Newton's law of cooling. So again stepwise answer. How? So step number 1, by Newton's law of cooling, d theta by dt, you can say here rate of change of temperature, that is equal to minus k theta minus theta 0, where theta 0 is the temperature of surrounding. So what are the given things? You just write here theta 0 means surrounding temperature. Here it placed in a room. So what is the temperature of that room? It is the 20 degree Celsius, and that is why theta 0 equal to 20 degree Celsius. And now the values, here t and theta are the variables. So find the values. So what are the given things here? Theta and t, make such type of table and put the values here. Given values, a body at temperature 100 degrees Celsius is placed in a room. It means that initially, means time is 0. That time temperature of body is 100 degrees Celsius. So here theta degrees Celsius, it is 100 degrees Celsius, is placed in a room whose temperature is 20 degrees Celsius and cools to 60 degrees Celsius in 5 minutes. Means after 5 minutes, temperature of that body is 60 degrees Celsius. Find its temperature after a further interval of 3 minutes. It means 8 minutes. After 8 minutes, what is the temperature of that body? So I can consider it is a theta 1. And what is it that we want to find? Now here theta 0 is constant, that is the temperature of room. So variables are theta and t. So I am getting here d theta by dt equal to minus k theta minus theta 0 is now 20. Now separate the variables. So we can separate the variables, that is the d theta upon theta minus 20 equal to minus k dt. So this is equation number 1, and which is a variable separable form, and we know what to do with variable separable form, that is integrating both sides. But now I am using, when I am integrating both sides, so integration of d theta upon theta minus 20, that is equal to minus k, it is a constant, and integration of dt plus integration constant, but instead of that I am using limits. So what are the limits? So here when t equal to 0, corresponding value of theta is 100 degrees Celsius, and when time 5 minutes, then corresponding value is 60. It means that by known values I will find value of k first, and after that by known value and unknown value I can find value of this unknown. So how to solve this one? Very easy. It's a routine now. It's a integration of d theta upon theta minus 20. It is a log of theta minus 20. Here lower limit 100, upper limit 60. That is equal to minus k t 0 to 5. So I am getting here log of upper limit. So these are the limits of theta. So 60 minus 20. So I am getting here 40 minus log of 100 minus 20. It is the 80. That is equal to minus k into 5. And that is why I am getting log a minus log b. By property of logarithm, I can write it is log a by b. So here 40 by 80, and that is equal to minus k into 5. So what is value of k? So therefore k equal to minus 1 by 5 log of 40 by 80. It means that it is 1 by 2. So this is a value of k. So equation number 2. Now again I will use the same, that is the variable separable form, but now I can introduce here unknown also. So now step number 3. Again from equation 1, which is a variable separable form. So that is why integrating both sides. So I am getting here integration of d theta upon theta minus 20 equal to minus k integration of dt. But now the values. When t equal to 0, corresponding value of theta is 100. When t equal to 8, corresponding value of theta is theta 1, which is unknown. So here when t equal to 0, 100 degrees Celsius, and we want to find after 8 minutes what is the temperature, that is the theta 1. So again by the same, that integration of d theta upon theta minus 20, it is a log of theta minus 20. Upper limit is theta 1, lower limit is 100. That is equal to minus k t 0 and 8 here. So upper limit, that is the limits of theta. So I can write here log of theta 1 minus 20 minus lower limit now 100. So 100 minus 20 I am getting it is 80. Here values of theta, and that is equal to minus k into 8 minus 0. Upper limit minus lower limit 8 minus 0. So that is why again here log a minus log b, I can write log a by b. So log of theta 1 minus 20 upon 80 equal to minus k into 8. So value of k from equation 2. So what is the value of k here? Value of k is minus 1 by 5 log 1 by 2. So that is why left hand side here theta 1 minus 20 upon 80, that is a log, and that is equal to minus k. Here k equal to minus, so I want minus k, so it will be plus 1 by 5 log of half. So 1 by 5 log of 1 by 2, it is value of k, and whole into 8. So that is why same thing I can write log of theta 1 minus 20 upon 80, that is equal to 8 by 5 log of 1 by 2. So log of theta 1 minus 20 by 80, that is equal to log of 1 by 2. This I can write as a power by property of logarithm. So I can write it is a 8 by 5. Power is 8 by 5. Now taking anti-log of both sides, so log get cancelled. Theta 1 minus 20 upon 80 equal to 1 by 2 raised to 8 by 5. So now we want value of theta 1. So what is the theta 1 minus 20? It is a 1 by 2 raised to 8 by 5 into 80. So what is this theta 1 minus 20? By calculator you can find here. So here I am getting by calculator, it is 26.39, and therefore what is the theta 1? It is a 26.39 plus 20. So that is why theta 1, it is the temperature after 8 minutes of that body, it is a 46.39 degrees Celsius, which is your required answer. Means it is the temperature of the body after 8 minutes. So which is your final answer. Now here is one interesting example. The temperature of body decreases at the rate of k theta, where theta degrees Celsius is the amount by which body is hotter than the surrounding air. The body is heated by a source which increases the temperature of body at the rate alpha t, where t is a time, alpha equal to constant. If this source is applied at t equal to 0, the body is then at the temperature of the surrounding air. Show that theta equal to this. So very interesting example. Here you just read carefully. Definitely we have to use here Newton's law of cooling. But here the temperature of body decreases at this rate, but at the same times by the source the temperature of body increases by this rate. And that is why by the Newton's law of cooling, so what is solution here? By the Newton's law of cooling, rate of change of temperature means d theta by dt decreases by the rate, so decreases, that's why minus k theta, and increases by the rate, so that is why plus alpha t. Note that here k and alpha are constant and variables are theta and t only. So solve this differential equation. So how to solve this differential equation now? Very easy. So here it contains d theta and 1 theta. There is no another function of theta, and that's why it is a linear differential equation in theta. So same thing I can write as a d theta by dt plus k theta equal to alpha t. As we know, the linear differential equation dy by dx plus p into y equal to q. So here y means theta and x means t. So you can compare, which is a linear differential equation of the form d theta by dt plus p into theta equal to q. So what is here p? It is a linear differential equation. So we should know how to solve linear differential equation. If we compare, so I am getting p equal to k and q equal to alpha t. So in linear differential equation, we want to find integrating factor first. So how to find integrating factor? E raised to integration of p dt, because here p dx it replaced by now t. So it is equal to e raised to integration of k dt, and that is equal to e raised to kt. And in linear differential equation, directly solution we can write. So hence solution of the differential equation is, so you can consider this is equation number 1 if you want. Actually in the general form, that is the y into if. So here instead of that it is a theta into if. equal to integration of q into if into dx means here now dt plus integration constant c theta into if, it is a e raised to kt, that is equal to integration q. What is value of q? It is alpha t into integrating factor e raised to kt dt plus c. So when we solve this one, so theta into e raised to kt, that is equal to u into v rule. So continue uv rule, we know that is the integration of uv dx. This is the continue uv rule. So by using that, I can consider here it is a u and this is a v, and that is why I am getting alpha t constant integration of e raised to kt is e raised to kt upon k minus derivative of alpha t, that is here. What is the derivative of it? It is alpha into integration of this. So it is a e raised to kt upon k. So already k, so that is why k square. If we consider the next derivative of this, it is a 0. That's why here bracket close plus integration constant c. So that is why I am getting theta e raised to kt equal to alpha t by k e raised to kt minus alpha by k square e raised to kt plus c. Now we want to find integration constant c. So definitely we have to use initial condition. So what is the initial condition? Note that. So by the initial condition, if this source is applied at t equal to 0, the body is then at the temperature of surrounding air. It means that there is no change. So theta also 0 there. Therefore, by initial condition, that is when t equal to 0, theta equal to 0 degrees Celsius, because the temperature of this body at the temperature of surrounding air. So therefore, so substitute these values in equation 1. So what we get? Theta equal to 0, so that is equal to t equal to 0, so 0 minus alpha by k square and e raised to 0, that is 1. So plus c. This implies that c equal to alpha by k square. Substitute this value in equation 1 and therefore equation 1 becomes. So therefore I am getting here final answer theta e raised to kt equal to alpha t by k e raised to kt minus alpha by k square e raised to kt plus c means alpha by k square. So we want theta. So divide throughout by e raised to kt. So theta equal to alpha t by k e raised to kt get cancelled minus alpha by k square e raised to kt cancel. If we divide by that, so plus alpha by k square divide by e raised to kt means here e raised to minus kt. So this is your required answer. So what we want to prove? You can see here. Actually, we want to prove this. So that is why simplify this. So alpha by k common. So theta equal to alpha by k common. In bracket I am getting. So alpha by k common. So only t minus. So alpha by k common. So 1 by k. Alpha by k common. So plus 1 by k e raised to minus kt, which is your required solution, or you can say hence proof.